Well, I'll do the worst.
Yeah. Yeah. Hi, everyone. I'm Jack, and today I'll be teaching Form 5 Chapter 1 Variation, Part 1, Direct Variation. The first part is to determine, okay, what is variation? Variation means that it is proportional to the quantity of the substance. Yeah, and it's denoted by this symbol. Yeah, this one. So this symbol means that y is proportional to x, right? Okay. The first part of the lesson will be determining whether a quantity varies directly as another quantity. If a quantity y varies directly as the quantity x, the y increases when x increases. The y decreases when x decreases. A quantity y varies directly as a quantity x if and only if y over x equal to k, where k is called a constant of variation. Y varies directly as x is written as y is proportional to x. When y is proportional to x, the graph of y against x is a straight line passing through the origin. All right. All right. B. Expressing a direct variation in the form of an equation involving two variables. Okay, we'll move on to the first example question. Given that y varies directly as x and y equal to 20 when x equal to 6, write a direct variation in the form of equation. So given that y varies directly as x, so y directly as x. So you know that in this topic, it become it will be y equal to kx. This is a formula. You know about this formula here. Yeah, y equal to kx. So it will be 20 equal to k times 36. So it will be k equal to 20 over 36. If you simplify, it will be 5 over 9. So y equal to 5 over 9x. This is the answer. Okay. And we move on to the next questions. Yeah. For this question, right? M is directly proportional to the square root of n. What's the relationship between m and n? So yeah, m is directly proportional to the square root of n. Square root of n. What's the relationship between m and m? So m equal to n to the power of half, right? We know that square root of n is n to the power of half. So the answer will be C. All right. And move on. The second exam questions. Given that m is directly proportional to p squared and m equal to 24 when p equal to 2, express m in terms of p. So m is directly proportional to p squared. M equal to 24 when p equal to 2. So m equal to kp squared. M equal to 24 when p equal to 2. K times p, which is 2, and square it will be 2 squared is 4. So it's 4k. 24 equal to 4k. So 24 divided by 4 will be 6. K equals 6. So m equal to kp square, right? Kp square. And k equal to 6, so it will be 6p square. The answer will be C. All right. Okay. Let's see. Finding the value of a variable in the direct variations. When y varies directly as x and sufficient information is given, the value of y or x can be determined by using y equal to kx or this formula y1 over x1 equal to y2 over x2. Right. The next formula. Given that y varies directly as x and y equal to 24 when x equal to 8, find the equation relating y to x. All right, so the method one is a y equal to kx stuff. So we know that yeah, we know that y equal to 24 and x equal to 8. The equation of y, the equation relating y to x. So y is proportional to x. Y equal to 24 equal to k times x, which is 8. So k equal to 3. So y equal to 3x. This is for part A. For B, right? The value of y when x equal to 6. When x equal to 6, so it will be 24 equal to k times 6. So it will be k equal to 4. Oh no, it's not, sorry, I did it wrong. For A, right, you got y equal to kx, right? Y equal to 3x, right? And x equal to 6, what will be? Y equal to 3 times 8. And no, 6, because when x equals 6. So you get 18 for C. Okay, this is of B, and for C, the value of x when y equals 36. So you sub in this formula again, it will be 36 equal to 3x. And then you get x equal to 12. So this is for C. Or you could also use another method, which is this formula. y1 over x1 equal to y2 over x2. So I'll show you how. So yeah, the equation relating y to x. So it will be 24 y1 over x1. It will be 24 over 8 is 3. So y equal to 3x for part A. And for part B, the value of y when x equals 6. Now sub in this formula, y1 over x1 equal y2 over x2. So it will be 24 over 8 equal to y2 over x2, right? y2 over x2. It will be 6 y2 over x2. So what will it be? Before. Wait. Or when x equals 6. Oh yeah, sorry. X equals 6. Oh yeah. Oh, sorry. Yeah. Wait. 24 over 8. 24 over 8 is 3. Right? Yeah. 3 equal to y2 over 6. It will be 3 times 6 you get 18 for B. For C, right? The value of x when y equal to 36. So I read it. Using this formula again, we get y1 over x1 equal to 36 over x2. 3 equal to 36. 3x2 equal to 36. So x2 equals to 12. You get the answer. All right, get it? This is how you do the questions. Okay, move on to example question from past year. Yeah, for D, right? If y is proportional to x to the power of n, x to the power of n, where n equal to 1, 2, half, 1, 2, 3, 2, 3. No, not 1, just half. It's half here. Y proportional to x to the power of n, where n equal to 1, half, 2, 3. Then the equation is y equal to kx to the power of n, where k is a constant. The graph of y against xn is a straight line passing through the origin. So y equal to xn. If y is proportional to xn and sufficient information is given, the values of variable x or variable y can be determined. Now, let's move on to the next question. The table shows some values of relations between variable x and y. Express y in terms of x. If you look at that, there are -2 in the multiple choice options. There are also square, cube in the multiple options. So it generally becomes y equal to k x n. So you sub in this formula. If it's y equal to kx, does it make sense? 24 equal to k times 2. It becomes 12, k equal to 12. And 24, 81 equal to k times 3. It becomes 27, k equal to 27. See, it's not really that in arithmetic form, in ascending form. So what we need to do is use y equal to k x n. So when x equal to 2, y equal to 24. So sub it into this 24 equal to k times 2 to the power of n. And then when x equal to 3, y equal to 81. So 81 equal to k times 3 to the power of n. So so this is equation 1, and this is equation 2. So using equation 1 divided by equation 2, you get 24 over 81 equal to k times 2 to the power of n over k times 3 to the power of n. So you simplify it, you get 8 over 27 equal to, the k is the same, so you can remove it, 2 over 3 to the power of n. Now, we know that 8 over 27, if you use a calculator, it's equal to 2 over 3 to the power of n. So what's the formula? What's it? 2 over 3 We know that 2 over 3 to the power of 3 to the power of cube is 8 over 27. So n equal to 3. So you solve it back, n equal to 3 to this formula. What do we get? Y equal to kx cubed. And then you solve it back in this formula. What do you get? 24 equal to k times 2 cubed. And k, you get 2 cubed is 8. 24 divided by 8 is 3. So k equal to 3. So the answer is y equal to 3x cubed. So the answer will be donkey, D. All right. Yeah, this is a smart tip for you. If the question asks you y varies directly at x, it's written as y is directly proportional to x. Y varies directly as a square of x, can be y directly varies directly as a square of x. Y varies directly as a cube of x, can be y varies directly as a cube of x. And y varies directly as square root of x, will be y proportional to the square root of x. And y varies directly as a cube root of x, will be y proportional to the cube root of x. Okay. Yeah, this will be my presentation for now. Right now, I'll pass on the lesson to the next presenter.
Thank you, Yongji. Okay, so I'm gonna share screen. All right, Jamie. All right, I think it's sharing. Okay, so thank you, Yongji. So for the remainder of the class, I'm going to be teaching you guys about the last two topics of variation, which are inverse variation and mixed variation. So let's just start it here. Okay, so topic 1.2, inverse variation. So first of all, let's start with an introduction and definition to inverse variation. So as we can read from the yellow box, in inverse variation, variable y increases when variable x decreases at the same rate and vice versa. You can interpret this as, as when y increases, x decreases. Almost the same as how Yongji explained direct variation, but the difference is that in direct variation, when y increases some value y, x increases. Okay, so inverse variation just basically means that when one value goes up, another value goes down. Compared to direct variation, which means that when something goes up, the other thing also goes up. So yes, this is the definition basically. When some value y increases, x decreases. So let's look at an example. Okay, let's let y equal the height of a building. Okay, just imagine this is a building or something. Okay, not very good at drawing. And let x equal air pressure. So if you guys learn physics, right, you know that the higher you go, the less air particles there are in the air. So you know that air pressure decreases when height increases. So if the height of a building increases, there are less air particles. And when there are less air particles, the air pressure also decreases. So we can conclude that y, which is the height of the building, varies inversely as x, which is air pressure. Okay, so let's look at one more example. Let's look at one more example, which is more, I guess you could say contemporary or more modern. Okay, so let's let z, some variable z, equals the length of the movement control order or MCO or lockdown, okay? And let b equal happiness. Okay, so this is just a funny example I came up with. So say, for example, one day, the government announces that MCO is extended. So this means that Z increases. And when I find out about this news, my happiness goes down. Or how you can express this in mathematical terms is B decreases. So as we can see from the pattern over here, these variables, one of these variables increases, which causes the other to decrease. So we can conclude that Z varies inversely to B. So those are two examples of how you can basically apply inverse variation to common everyday events that happen in your life. So let's move on to an example. Okay, so I took this example from the textbook. This is example 15. I forgot which page, but let's read it out. Okay, so Chia Ming takes part in a 42-kilometer marathon. The table below shows the relation between the time taken by Chia Ming and his average speed. So I want you guys to look at the time. Okay, so the time over here from 4 to 8, we can tell that T increases. Now, look at the average speed. The units are in kilometer per hour. We can see that for every consecutive hour, it decreases from 10.5 kilometers per hour to 8.4 kilometers per hour. We get a decrease of about 2.1 km per hour. And from 8.4 to 7, we get a decrease of 1.4 kilometers per hour. So we can conclude that the velocity or speed, the speed decreases as time increases. It goes that way. All right, so now let's look at the question. State the change in average speed if the time taken increases by 2 times. Okay, so basically how you solve this question is you need to find two values of time, because they say it's time, right? Time taken, that satisfies this specific requirement. Okay, increases by 2 times. Okay, which values of t can increase by 2 times? So just by looking at this directly over here, I can already tell it's 4 and 8. Because 2 times of 4 is 8. 2 times of 5 is 10, but there's no 10 over here. So we can't take this, this, or this. Okay, so it's 4 and 8. So state the change in average speed of the time taken increases by 2 times. So now we have to look at the respective speed of the time. So we see here that it is 1050 and 5.25. So now you want to find the increase. So you just take 10.50 minus 5.25. Now I'll just put that in my calculator and we will get 5.25. We can't forget the unit, kilometer per hour. Okay, so that is the average increase when the time taken doubles. Okay, so now let's look at B. Decreases by 1.5 times. Okay, so basically to find the two values, you have to apply trial and error. So when B decreases by 1.5 times, let's just put it in the calculator. When B decreases by 1.5 times, you get 5.33. And we have a 5, but we don't have a 5.33. So let's try the next value. 7 divided by 1.5. You get 4.67. Again, we have a 4, but it's not a decimal. Well, okay, so now let's try 6. 6 divided by 1.5 is equal to 4. Okay, so now we have a number. We have two sets of numbers, 6 and 4, that are both stated in the table. So we can take both of those two. So now we want to state the change in average speed when it decreases by 1.5 times. So it goes from 6 to 4. So that means you go from 7 to 10.5. So instead of 10.5 minus 7, you now take 7.00 minus 10.50. And when you put that in a calculator, you will get negative 3.5 kilometers per hour. Okay, so those are the answers for A and B. It's imperative that you take note that increase usually means a positive and decrease usually means negative. Okay, so feel free to take note of that. Let's move on to the next part, which is inverse variation equations and graphs. Okay, so let's look at the text here. For an inverse variation, y varies inversely as x can be written as y is proportional to 1 over x, which is the variation relation, which is how you basically express inverse variation in mathematical notation. So, okay, sorry for the background noise. Okay, or as Yongji said just now, y directly proportional to x can be written as y is equal to kx. You can do the same for inverse variation as well. So you might be wondering why it's y equals k over x instead of y equals like kx. So let me tell you why, okay? So when you substitute the constant in, for example, if y is directly proportional to x, it will be y is equal to kx, okay? But when you take into account inverse variation, y varies inversely to x, what you're actually doing is you're trying to find the constant that multiplies by this over here. So what you're doing is you're just inserting an x and you're multiplying that by 1 over x. And as you know, by rules of multiplication, k over 1, and then you just times it across, y is equal to k over x. So that's how you get inverse variation in the equation form, okay? So now let's look at the graphs. Okay, so these are the two main graphs that you'll be seeing in inverse variation. Okay, pay close attention to the axes because those are important. So as you can see from the vertical axis, it's labeled y. From the horizontal axis, this is labeled x. When the graph is like this and it's inversely variable, okay, you will get a parabola. A parabola basically means a graph that does not touch the y or the x-axis, okay? So it just looks like this. Okay, y over x, okay? I'm just gonna extend it out here because this is the graph of y is equal to 1 over x. Okay, you have that graph there and you have this graph there. That's the graph of y equals 1 over x. And you can take note that both of these don't touch the y or the x-axis. They get close, but they never actually touch it. So now let's look at the equation. Sorry, let's look at the graph. Let's look at this graph. Pay close attention to the vertical axis. It's labeled y, while the horizontal axis is labeled 1 over x. And as you can see, the graph is actually a straight line starting from the origin. And it's dreadfully similar to y equals x. So basically what we're doing over here, right, is we're using the x-axis, but just, you know, replacing it with 1 over x. If you learn at maths, you'll recall this equation, y equals m capital X plus c. What you're basically doing is you're replacing the y-axis with y and you're replacing the x-axis with 1 over x. Okay? So yeah, that's just another way to interpret graphs. These two graphs are the same. These two graphs are equal. Okay? They both mean the same thing. It's just different ways to interpret data. Okay, so let's move on to the next one. Okay, so we have an exercise that I like to try. So given that y is equal to 0.5 when x is equal to 16, calculate the value of y when x is equal to 0.04. Okay, so the first one is very straightforward. If y varies inversely to x, y should be equal to some constant multiplied by 1 over x. So now to find the value of this constant, we just plug in the values. So 0.5 is equal to k over 1 over 16. So now, When we try to find the value of k, we get 0.5 times 1 over 16. K is equal to 1 over 32. So now from this, we can form a new equation by subbing k back into the original. So y is equal to 1 over 32 multiplied by 1 over x. And you can multiply straight across. You get 1 over 32x. But we're not done yet. This is just the equation. They want you to calculate the value of y when x is equal to 0.04. So now to find the value of y, all you have to do is sub back into this equation 0.04. And when you input that into a calculator, you will get y is equal to 25 over 32. So that's the answer for A. Now let's look at B. So we have the inverse cube, okay? It basically holds the same principle. Let's do it together. So as usual, it'll be y inversely variated to the cube of x. So y is equal to some constant multiplied by 1 over x cubed. Now you just sub in the values again. 0.5 is equal to k multiplied by 16 cubed. Okay, let's just put that in the calculator. And you get k is equal to 2048. Now we can sub back into the original equation and you will get y is equal to 2048 multiplied by 1 over x cubed. Or you can simplify it to get 2048 over x cubed. Now you want to find y when x is equal to 0.04. So now you just sub x back into the equation. 0.04 cubed. You just put that in a calculator. You get a very big number, 32 million. I like to put my answers in standard form. So we'll just do it that. We'll just do that. 3.2 times 10 to the power 7 or 32 million. Okay. So now let's look at C. Y is inversely varied to x to the power 1 over 2, or as we all know, when a number is raised to the power 1 over 2, we know that is the same as square root. So first of all, we can rewrite this as y varies inversely to the square root of x. Now we can do our usual tactics and sub in the values. 0.5 is equal to k over hold on, k over 16, right? Yeah. So 4. Oops, okay. Accidentally wiped out the board, but it's okay. Let's just rewrite that again. Is equal to k over square root of x. So 0.5 is equal to k over square root of 16. So you get 4. Right? And then 4 times 0.5 is 2, so we'll get 2 is equal to k. Now, you just sub it back into the original equation. Y is equal to 2 over square root x. Then you get y is equal to 2 over the square root of 0.04. And then 2 divided by the square root of 0.04 is 10. And that's your final answer. Now let's look at D. It's a bit more peculiar. So y varies inversely to the cube root of x, or we can also write this as x to the power 1 over 3. So we can write this as y is equal to, again, constant multiplied by the 1 over x to the power 1 over 3. Now just insert the values. 0.5 is equal to k over 0.04 to the power 1 over 3. Let's put that in there. Oh, sorry, no. Not 0.04, sorry. It's 16 to the power 1/3. Okay. Okay, wait, let me just put that in the calculator. So you don't actually get a finite number, you get an irrational number. So we'll just keep that as cube root of 16. So cube root of 16 times 0.5 is equal to k. Or you can approximate, you can do whichever one. I like to use the more, what do you call it, the more definite way, which gets you the exact number. So then you can just put that back into your equation. 16. Sorry, what am I doing? Sorry, yeah. Cube root of 16 times 0.5 over x. Now you just sub 0.4 back into x and you'll get the value of y. Okay, let's just do that real quick. Sorry, to the power 1/3. Yeah, let's put that in there. Cube root 16 multiplied by 0.5 divided by 0.04 to the power 1/3. You'll get this weird looking number, which is 94.49. So that's the answer for D. So we finished all the examples. I hope you understood most of that. I don't like the ones where they don't result in whole numbers or integers because then it's not intuitive to find out the right answer. But let's move on. Okay, so let's look at some graph examples. Okay, pay attention to the pointer. Two quantities x and y vary based on the table on the right. Well, it's not on the right, but here it is. On the right, on the bottom. By using a suitable scale, draw a graph of y against 1/x and show that y varies inversely as x. Okay, so the graph is drawn for you already over here. But so basically you find the k constant, okay? You find the k constant and then you plot your graph accordingly and you make sure that your vertical axis is labeled y and your horizontal axis is labeled 1/x. If you draw your graph like this, that's incorrect, okay? Because they are asking you to draw the graph of y against 1/x. So just by reading this, you need to know that y against x is equal to the y-axis against the 1/x axis, okay? So pretty much the rest is just substitution and finding out what the k constant is so that you can find out the gradient of the graph, okay? So let's move on. Applications of inverse variation. So if you take physics or take mechanics, you'll learn about Boyle's law, where pressure is inversely proportional to volume, okay? So let's just read about how inverse variation can correlate with Boyle's law. So let's read it. According to Boyle's law, the gas pressure P of a mass of gas is inversely proportional to the volume of gas V. So from this already, I can tell that P is inversely related to 1/V. Inversely proportional to volume of gas V. If the temperature of the gas is fixed, the diagram on the right shows the gas trapped in a cylinder. So just assume that there are many gas particles stuck inside here. When the volume inside the cylinder is 80 centimeter cube, the gas pressure is 190.25 kilopascals. Calculate the volume of the gas in centimeter cube when the gas pressure inside the cylinder is 121.76 kilopascals. Okay, so don't be afraid by all the physics terms like pressure or Boyle's law or like gas particles or whatever. Just look at this from a mathematical standpoint, okay? So when we look at this question, we can already tell that P is inversely proportional to V, right? So let's move on with the maths. So we can convert this into some constant multiplied by 1 over V. Now they gave us information on the volume and the pressure of the cylinder. So when the pressure is equal to 190.25 kilopascals, you keep K, the volume is equal to 80 centimeter cube. So when you try and calculate the value of K, you'll get 15,220. Okay, and this is just a constant. There's no unit behind it. And when you sub that back into the original equation, you'll get pressure is equal to 15,220 divided by volume. Okay. So now they want you to calculate the volume of the gas in centimeter cube when the gas pressure inside the cylinder is 121.76 kilopascals. Okay, so basically you're subbing in P, right? But you want to find V. So you don't have to do this, but what I recommend you do first is you express V in terms of P. So to do that, it's simple, right? Okay, just times both sides by P times both sides by V. Then this cancels and you get PV is equal to 15,220. Then you divide both sides by P. Then this cancels. So you get V is equal to 15,220 divided by P. So now you have V in terms of P, or the volume in terms of pressure. Now you can find the volume. So V is equal to 15,220 divided by 12176 kilopascals. So if you put that in a calculator, you will get 125 centimeter cubic because it's volume. Okay, you can't. Please make sure to remember to put your units because it's imperative that you do so. So now we're going to move on to topic 1.3, which is mixed variation. So we have a brief introduction over here. So mixed variation or combined variation, as you can see from this, is basically a mix of, it's very intuitive from the name. It's a combination of inverse variation and direct variation. So you're just combining the two of them. So for example, y is directly proportional to x of m, and y is inversely proportional to z to the power of m. When you combine these two, you'll get y relates like this and like this, as you can see from over here. So where m is equal to either a whole number, a fraction, or usually the power is either a whole number or a fraction. It's never something irrational like pi or e. Yeah, it's usually a whole number or a fraction. Okay. And as you can tell in the equation form, there's a k here, but how do you get that k? Simple, it's a constant. So it's just k multiplied by the x to the power of m divided by z to the power of n. Okay. And as you can apply the rules of multiplication of fractions, you'll get y is equal to k x to the power of m divided by z to the power of n. Okay. So let's move on. Okay, so we have an exercise. It is given that y varies directly as the square of x and inversely as the square root of x. If y is equal to 8, when x is equal to 4 and z is equal to 36, express y in terms of x and z. So let's look at this from a strategic standpoint. So y varies directly as the square of x, directly as the square of x. So y varies directly with the square of x. And y varies inversely as the square root of x. So we can write that as this. Sorry, square root of z. So when you combine these two, combined variation, y varies to this. Okay. So now you want to express y in terms of x and z, right? So we need an equation. So this becomes y is equal to k multiplied by x squared divided by the square root of z. So now we need to find the constant k, which means subbing in y, x, and z. So we just sub that in. Y is equal to k multiplied by 4 squared divided by square root of 36. And we can try and figure it out. 8 is equal to k, 16 divided by 6. Okay, so we can put that in the calculator to find k. K is just 8. You divide both sides by 16 over 6. Okay, then you can cancel this. So 8 divided by 16 over 6, which is equal to 8. You just when you divide a fraction with a fraction, you just flip the bottom here. So the 6 on the bottom goes on top, and then you can multiply it across. So k is equal to 3. Okay, so now we have found the value of the constant. Now we can get the equation. Just sub it back into the k over here. Y is equal to 3 x squared over square root of z. And we can write that down as 3x squared over the square root of z. Now, this is the equation. This is the final answer. You have it. You're expressing y in terms of x and z. So this is the final answer. Okay, so I hope you were able to follow and it wasn't too confusing. Let's move on to example 2. So, sorry, exercise 2. So how do you solve problems involving combined variation? So I took this example from the textbook. So let's have a look. Okay, the pressure P in Newton per meter squared on the tire of a wheelbarrow varies directly as the mass of the wheelbarrow m kilograms and inversely as the surface area of the tire touching the ground, L meters squared. It is given that the pressure on the tire is 45,000 Newton per meter squared. When the mass of the wheelbarrow is 90 kilograms and the surface area of the tire touching the ground is 0.02 meters squared, calculate the value when m is equal to, calculate the value of P when m is equal to 120 and L is equal to 0.5. Okay, so first off, let's interpret what they're saying here, okay? While paying attention to these units. So pressure P, okay, varies directly as the mass of the wheelbarrow m. So we know that P varies directly with m. And now we know that P varies inversely as the surface area of the tire touching the ground, L. So we know that P varies inversely with L. So when we combine these two, we get P is related to M over L. Okay? You're basically times it, you're basically multiplying these two together. Okay? So now we want to turn this into an equation. So we get P is equal to K multiplied by M over L. So now they've given us some values. So we have the pressure. So make sure when you get the values right, you make sure that the units line up. So they're giving you a very big hint as to which to sub in. Okay, so pressure is 45,000 Newton per meter squared is equal to K multiplied by M, which is 90. Okay, and as you can see, the units here are the same, so you don't have to do any conversions. So it's 90 divided by the surface area, which is 0.02. Okay, and you see that the units are the same, so you don't have to convert anything. So K is equal to 90 divided by 0.02, 45,000 divided by 4,500 is equal to 10. Okay, so now we have the value of K, and we can just sub that back into here, and we can get P is equal to 10 multiplied by M over L. Then don't forget to apply the rules of multiplication of fractions, and you get 10M over L. So this is just the first part. We haven't even started. Sorry about that. Okay, let's continue on. So P is equal to 10M over L. So we aren't even done yet, okay? So we haven't even gotten to solving the question yet. So let's look at A. Calculate the value of P when M is equal to 120 and L is equal to 0.5. So we have our equation, and they want you to calculate P, which is easy because we already have the expression for it. So P is equal to 10M over L. So we can just sub in the values of M and L, and you get P is equal to 10 multiplied with 120 divided by 0.5. So when you put that into a calculator, you'll get P is equal to 2,400. Don't forget your units. Pressure is equal to Newton meter square. 2,400 Newton meter square. Newton per meter squared, sorry. That's the answer for A. So now let's look at B. What can be done to reduce the pressure on the tire if the mass of the wheelbarrow is fixed? So I guess you can count this as a K-BAT or a HOTS question. So what can be done to reduce the pressure on the tire if the mass of the wheelbarrow is fixed? So when they tell you that the mass of the wheelbarrow is fixed, right? It means that the wheelbarrow, the mass is a constant, okay? So basically, let's just equate that to 1, for example, okay? Let's just let the mass is equal to 1 kg, okay? So the mass stays constant and then you divide it by L. So now we're gonna apply a bit of our knowledge of inverse variation to find out what can be done to reduce the pressure on the tire. So as we found out from just now, P is inversely varied to 1 over L. So that means when P increases, L decreases. So what can be done to reduce the pressure on the tire? So as we learned from just now, if we want to decrease the pressure on the tire, according to what we learned just now, if P wants to decrease, then L has to increase. And this also makes mathematical sense in the option that P, for example, say we have 2, okay, 1 over 2. So P is equal to 0.5. So that's one number. But say we take a larger number for L, say for example 10. So P is equal to 1 over 10, which is 0.1. And as you can see, P, when L equals 10 is smaller than P when L equals 2. So when L increases from 2 to 10, P decreases from 0.5 to 0.1. So in order to reduce the pressure on the tire, if the mass of the wheelbarrow is fixed, so you just don't take into account the mass, you want to increase the surface area. So in how you would answer this in exam would be like, sorry, let me just clear the board a bit. Okay. So how you would answer this in exam would be to reduce the pressure on the tire, the surface area should be reduced it should be increased with the mass remaining constant. Meaning M doesn't move lah, because if M gets bigger, then P also will get bigger. Okay, so that's how you'd solve this in exam. So that's basically it for the entire topic. I've actually prepared some KBAT questions, but it looks like we're running a bit low on time, so I don't think I'll be able to finish it this class. So I guess we will end it there. So yeah, class dismissed, I guess.
Hey, Idris.
Yeah.
The class is the class is now postponed to 10 p.m.
Wait, 10 p.m. Oh my God, I forgot. Oh, okay, I guess we can continue with KBAT questions then. So sorry, guys. Okay. So let's just start. Let's just start with some KBAT questions, okay? Wait, it's 9:30 right now. Okay, you know what? Since you guys have been studying for about an hour, I'd like to give you guys a break first, 10 minutes, then we can start with the KBAT questions, all right? Okay, so I prepared like 3 or 4, but come back at around 9:40 and we'll start with the KBAT questions. All right, okay, thank you guys. Okay, it's 9:40. I hope you use that 10-minute break well. So let's continue on with the final 20 minutes with some K-Bar questions. Okay, so let's start with the first one. Okay, let's have a read. Mr. Kamal wants to install rectangular tiles in his bedroom. The number of tiles needed, J, varies inversely as the length P, meter, okay? Pay close attention to the unit, and width, L, also meter, of the tiles used. Mr. Kamal needs 120 pieces of tiles if the tile is 0.4 meters in length and 0.5 meters in width. Okay, A, calculate the number of tiles needed if the length is 0.2 and the width is 0.3. Okay, that was a bit much, so let's try and digest it bit by bit. So, Mr. Kamal wants to install rectangular tiles. The number of tiles needed, J. Let's write down J varies inversely as the length. Okay, so J varies inversely with P. And J also varies inversely with the width, L. So as we learned from just now, we can just combine these two by multiplying these two together. And you'll get J varies with 1 over P over L. PL of the tiles used. So Mr. Kamal needs 120 pieces of tiles. All right, so we can rewrite this as an equation as K multiplied by 1 over P over L. And we can find the value of P first. Sorry, we can find the value of K first by just subbing in. Okay, so 120 is equal to J. And then you just have K over here. And then the length of the tiles is 0.5 and the width is 0.5. So 1 over 0.5 multiplied by 0.5. So when we simplify that, we get 120 is equal to K multiplied by 1 over 0.5 multiplied by 5. So now we have the value of K, our constant, is equal to 120 divided by 5, which is 24. So now we have our value of K, and we can substitute that into our equation. So J is equal to 24 multiplied by 1 over PL. And let's just clear the board so we can rewrite that more cleanly. 24 over PL. So now we can start solving question part A. Calculate the number of tiles needed if the length is 0.2 meters and the width is 0.3 meters. So this is simply a case of just substituting everything back into the equation. So you get J, which is the number of tiles, is equal to 24 divided by 0.4 multiplied by, sorry, not 0.4, 0.2 multiplied by 0.3. So we'll get J is equal to 24 divided by, let's just input the 0.2 times 0.3 into the calculator. J is equal to 24 divided by 0.06. And then when you calculate all of that, you'll get J is equal to 400 tiles. So that's the answer for A. Let's look at B now. If the area of the tile increases, what is the change in the number of tiles needed? Okay, so you're going to need to think a bit outside the box for this question. So they're not asking for the length or the width, if the length of the width of the tile increases, but they're asking for what happens if the area increases. So if we look back at this, right? So P is equal to the length and L is equal to the width. And as we recall, area is equal to length multiplied by width. So we can denote this mathematically as A is equal to P multiplied by L, because P is length and L is width. So now we can just sub this back into the original equation. But first, let's see what happens. So J varies inversely to A. So yeah, you can just sub this back into the original equation and you'll get J is equal to 24 divided by A, because A is equal to PL. Okay, so you're just subbing this back into here. So what happens? Okay, so if you want if the area of the tiles increases, right, what is the change in the number of tiles needed? So as we learned just now from inverse variation, if J were to increase, okay, let's just look from here. If J were to increase, A would decrease, and vice versa. If A increases, J decreases. Okay. So if the area of the tiles increases, the number of tiles needed, sorry, it's not this one, sorry. If the area increases, the number of tiles needed decreases. Okay. And you can look at it as, okay, say we have a square floor, right? Okay. And the tiles here, and these are the tiles, okay? Let's just imagine that, okay? And they have width P and L. So P and L is equal to area. So the area of this is small. So you can fit many, many different tiles into this small space. But let me just kill the bot real quick. If you have that same square room and now your area is suddenly bigger, you can fit less tiles on the floor. So that means that if the area increases, the number of tiles you can fit in this constant space decreases. So if you want to answer that in exam, you basically just say, if the area of the tile increases, the number of tiles needed for, okay, this is gonna be a really long answer, so bear with me. For Mr. Kamal to install in his bedroom decreases. All right, so that's how you solve A and B. So let's move on to the next K-back question. Okay, so this looks like a long one. Let's read it. The average number of daily phone calls, C, between two cities varies directly as the population of the two cities P1 and P2, and inversely as the square of the distance J between two cities. The distance between city A and city B is 210 kilometers. The average number of daily phone calls between the two cities is 15,750. Sorry, and the populations of city A and city B are 105,000 and 220,500 respectively. Give your answer to the nearest whole number. Calculate A. The distance between city P and city Q if the populations are 83,400 and 62,000 respectively, and the average number of daily phone calls is 19,151. So upon reading all of that information, it's really not that easy to take all of it in at once. So what I like to do when answering questions like these is to take it bit by bit, okay? So we know that the average number of daily phone calls C is directly proportional or varies directly as the populations of two cities P1 and P2. So let's just write that down. First of all, real quick. It varies directly as P1 and it varies directly as P2. Okay, so we have this first part covered. But now we also know that C, or the average number of daily phone calls, is inversely proportional or varies inversely as the square of the distance J. So let's write that down real quick. Because if it varies inversely to J squared, because they say square of the distance J between the two cities. So the distance between city A and B is 210 kilometers. The average number of daily phone calls between two cities is 15,750. Okay. And the populations of city A and B are 105,000 and 220,500 respectively. So they're giving you all these values here, right? So that you can sub it back into the equation. but right now we don't know which to sub it in. So let's look at the question here. The distance between CTP and CTQ, if the populations are 83,400 and 62,000 respectively, and the average number of daily phone calls is 19,150. So now we know that we need to find the distance between CTP and CTQ, right, which is J. So as we learned just now, we want to combine all of these by multiplying all of them. So we'll be getting C varies to P1 multiplied by P2 over J squared. Okay. So now we can rewrite this in equation form. K multiplied by P1 multiplied by P2 divided by J squared. So we're going to rewrite this again by putting the rules of multiplication. Fractions can multiply straight across. So K P1 P2 over J squared. So we have this equation. Okay. So now we want to find K. So we have all this information over here. So we can put that in. Okay, the average number of daily phone calls between two cities is 15,750. So we know that the average number of daily phone calls is C. So we can input that value over here. Now K is a constant, so you don't sub anything into K. Remember that. So the distance is 210 kilometers. Okay, so, and as we can tell, the distance J. All right, so since it's squared, we have to square it. And then P1 and P2. So city A and city B. So it's 105,000. It's going to be long. Multiplied by 220. Yeah, that value over there. So now we can multiply straight across and simplify everything a bit. Divided by 210 squared. Okay, so you'll get 15750 is equal to K multiplied by 525,000. And then you'll get K is equal to 15750 multiplied by 525,000. So you'll get K, the constant, is equal to a nice decimal 0.03. Now you can just sub that back into this equation and you'll get C is equal to 0.03 multiplied by P1 and P2 over J squared. So I'm going to clear the board a bit so that I can write that. C is equal to 0.03. Actually, let's write that in fraction form. 0.03 is equal to 3 over 100. Okay, so 0.03 is equal to 3 over 100. So we can write that as C is equal to 3 over 100 multiplied by P1 and P2 over J squared. And then multiply straight across. 3 P1 P2 over 100 J squared. I just like doing it in this form because it's a bit more neat instead of just putting 0.03 multiply, yeah, blah, blah, blah. So now let's look at A. Okay, they want you to find the distance. Okay, so they want you to find the distance. So you were gonna have to rearrange this equation a bit. You don't have to, but I prefer to do it that way. Okay, so to rearrange the equation, we need to express J in terms of all the other variables, right? So just multiply across a bit. 100J squared is equal to 3P1 P2 divided by C. Now we divide by 100 on both sides over 100 C, okay? Because you divide both sides by 100. Timesing by 1 over 100 is the same as dividing by 100. So this and this cancel. And then C times 100 is just 100 C. Now we can put J is equal to plus or minus, because when you square root something, it has to either be plus or minus. 3P1 P2 over 100C. But let's look at the question again. They're asking you for the distance, right? And distance can only be positive. It's not displacement. So J should be equal to positive 3P1 P2 over 100C. Now, finally, we can find the population, the distance by subbing in all of these values over here. So j is equal to the square root of 3 multiplied by 83,462,000 divided by the average number of phone calls, which is 100 multiplied by 19,151. All that square rooted. And you will get, let's just multiply everything real quick. Hundred times 19,151. Wait, hold on. Okay. Hold on, yeah. It's a very big number. Okay, you'll get square root of 8,100 rounded off lah. So you'll get square root of 8,100 is equal to 90 kilometers. So yeah, after all of that work, we finally have found the distance between the two cities, and we're not even done yet. So let's continue with B. Okay, the population of this, oh wait, hold on, let me just rewrite the equation just now. 100j squared, okay. The population of city J, if the population of city K is 1.1 million with the distance between the two cities is 351. And the average number of daily phone calls between city J and city K is 18,857. So as we can recall from just now, P1, P2, hold on, let's see. The average number of daily phone calls is, okay, so P1 and P2 you can just equal it to either one. It doesn't matter if you sub in 1.1 million into P1 or P2s. But first of all, let's express it in terms of either one of those. So I'm going to choose P1. So from the original equation, C is equal to 3 P1 P2 over 100j squared. I want to express P1 in terms of all the other variables. So I'll multiply both sides by 100j squared. These and these cancel, so you'll get 100j squared times C is equal to 3P1 times P2. Now I want to get rid of 3P2, so I'll divide both sides by 3P2. This and this cancel, and then you get P1 is equal to 100j squared C divided by 3P2. Okay, so now we have our equation to find the population of city J. So all we have to do is sub these values back into the original equation. So you'll get P1 is equal to 100 multiplied by 351 kilometers squared multiplied by the average number of daily phone calls, which is 18,857, and then divided all by 3 times P2, which is the population of the other city, which is 1,100,000. Okay, so now we just gotta put that all, you just gotta do the maths real quick for that one. Times 18,857. Okay, it's a big number, so it's 2.32 times 10 to the power of 11 divided by 3 times 1. Okay, wait. Oops, yeah, okay, right. Okay, this equals 70,400.0. So, and this is equal to 33000. So yeah, we don't have to square it or anything. Just make sure to put down the unit. Actually, no, for this one, you don't have to write down the unit, but like, it's better if you know that this is people, right? So 70,400 people. So that's the amount of people in population of city J. So I think we have time for one more question. One more, just one more. Yeah, this isn't Kebat. Actually, no, this is Kebat, pretty Kebat. Is it? Nah, okay, it's pretty easy. So let's just go through with it. Write in the form of variation and in the form of equation for each of the following combined variations. Okay, so this is more combined variation exercise. W varies directly as the cube root of V and inversely as the square root of X. So W varies directly to the cube root of V, and W varies inversely to the square of X. So when you want to combine these two, just make it like square root 3 multiplied by 1 over x squared, multiply them across, and you get C varies to this expression over here. Okay, that's the answer for the first one. Now let's look at B. F varies directly as G and H to the power of 3, and inversely as square root of T. So we can write it down as F varies directly as G and H cubed. Okay, and then we can write down F varies inversely with square root of T. You can also separate this and this. You can turn it into F varies with G and F varies with H cubed. These two combine to get this. And then we combine this and this, you'll get, sorry, it varies inversely. You get F is equal to G H cubed over square root of T. Okay, now let's look at the final question. See, the acceleration of an object A varies directly as the distance traveled S, and inversely as the square of the time taken T by the object. Okay, so they're trying to confuse you a bit over there, but let's just look at it. Okay, so A varies directly to the distance traveled, and A varies inversely to the square of time taken. So you combine this and this is equal to S multiplied by 1 over T squared, and you will get A varies by this expression over here. Okay, so that seems to be the end of our presentation, of my presentation. And yeah, I hope you guys have learned something from this. Wait, let me see if I can stop sharing. Okay, yeah. So I hope you guys learned something, well, not learn something new lah, but like I hope you guys were able to follow through that lesson all in all. And come back next week for more variation fun, I guess. Okay. So thank you guys for coming. I guess I can dismiss class now. Is that right, Halim? Okay.
I can.
Yeah, you can.
All right. Okay. Class dismissed. Thank you guys. Bye-bye.
Thank you.